Can screams really be turned into energy? And if so, do children make more energy than adults? Does laughter make more energy than screaming? Today we find out. Oof. The most important part of this project is capturing the vibrations that travel through the air that are produced by our mouth holes, also known as sound. My first idea was to use a mic. Yes, a mic, like this one. Mics take sound vibrations and convert it into the digital world for our computers to read. Did you know that some mics can create their own energy? Dynamic and piezo mics are examples of these types of technologies that can create their own power just by speaking into them. Back in the day, we actually had sound-powered telephones. Pretty neat, eh? Dynamic mics are based off of magnets and coils, which you're probably pretty familiar with. Piezo mics, however, are based on the magic of crystals. Wow. Goodness. Beautiful. Quartz crystals, to be exact. I'm going to start my experimentation with piezo mics because, well, I mean, they're magic crystals. Why wouldn't I start there? You may be familiar with this amazing crystal technology if you own an electronic drum kit. See, these sensors can be used to detect how hard you're hitting them and adjust the outputs correctly. These devices are really cool, actually. When they're stressed mechanically in a certain direction, the protons and the electrons are moved in a certain direction to create energy. Now that we know what kind of tech we're going to be using, let's build the circuitry to read it. I'll be using an Arduino Nano, our computer, to read the input signals. The simple answer would have been to use an amplifier, like I have here for a bass speaker. These can take really small electrical signals, like what you get from a mic, and amplify it up to something that can be played back on a speaker or read into our Arduino. However, amplifiers use external power to boost that signal up. Since I wanted to see how much power could be generated just by my mic, I found this to be a little bit cheating. So thus began the long journey into finding a way to read that really tiny signal into my Arduino computer. I started by trying to read the sensor directly into the Arduino computer. For that, I began by hitting it, and that was easily picked up by the device itself. Unfortunately though, when I tried to scream at it, "You should be better," repeatedly, it didn't do anything. So then I said, what stores energy temporarily? A battery, of course, so simple. But no battery I know can store that little amount of energy. However though, I could use something similar, a capacitor. This is like a battery, except it can store really small amounts of energy. Perfect for what I was doing. So then I started experimenting. Even the amount of electricity that was being generated by the piezoelectric sensor through my voice was too small for these capacitors. It seemed like nothing was going to work at this point. So I started looking into alternatives. I came across this individual named Edouard Leon Scott de Martinville, who invented something called the phone autograph. Yes, it's exactly how it sounds. It can take sound and turn it into a written message. Really cool. That's neat and all, but how does that actually help us here? Well, if he can take sound and turn it into energy in the form of a stylus writing, why can't I capture the energy of that stylus writing itself? So I went back to the basics. I'm now using this speaker as a mic. Fun fact, you can actually use speakers as mics. The technology is interchangeable. Anyways, how is the speaker going to help us at all? My idea was simple. By using a bigger diaphragm, I could capture more sound through the air than with a tiny little mic like a piezo mic or something like that. When sound hits the diaphragm, it moves a magnet attached to the centerpiece here into a coil, which then generates an electrical signal on the output here. We should be able to take that electrical signal and input it into our Arduino computer to read it. And yes, that means we've ditched the piezo. No more crystals. My voice hurts after all this. I have to admit, at this point, I've been tinkering around and it looks like I'm going to have to use an amplifier. But don't worry at all. That's completely okay for this experiment. See, the reason we actually need an amplifier at all is because our little Arduino computer just can't read anything below 4 millivolts. To put that in perspective, when I was yelling 1 inch away from the microphone at max volume, I was getting a reading of 100 microvolts. That doesn't work for our application with our Arduino. I also tried the capacitor idea again. However, it turns out that the capacitors discharge faster than I can charge it with my voice power, so that was tossed out entirely. So basically, instead of storing power like it's represented in the movie, all we're gonna do is read the energy levels from the mic every so often, add those together, and then display it out, all within a 5-second period. Now that we've figured out all the hard parts, we can just put it together. It has all of these features: a button for starting the timer, an energy display for how much screen power was generated on a scale of 1 to 10, an on-off switch, a speaker for outputting sounds, the mic input, and, of course, the authentic to the looks of the canister from monstersinc. It's done. Let's try it out. Ooh, what'd I get? 1, 2, 3, 4, 5, 6 out of 10. What's 6 out of 10? 6 out of 10 is playing Fortnite for 7 billionths of a second. That would mean I would have to scream at that level for 4.5 years to play it for 1 second. That's pretty crazy. Let's see who makes more energy now. Children, women, men, animals. I have some speakers here. I have the scream canister over here. Let's get testing. Cockatoo, 1 bar. 1 bar for the husky. So what I'm gonna do here to compare male and female voices is I've taken the male range of frequencies and the female range of frequencies, added the extremes together, divided by 2 to get the average voice range, which is 130 hertz for men and 210 hertz for women. So I'm gonna start with the men here, and then I'm gonna do the women after. One bar for men. Whoa, look at that, full bars for women. So from this quick test, higher frequencies give us better results on our device.
And that makes sense because power is equal to 1/2 UW squared A squared V, where W is equal to the angular frequency of a wave, which is equal to 2 pi F. So by looking at this equation and ignoring everything except for W, and subbing in this guy here, we know that wave power is proportional to the frequency. So the higher the frequency, the more power you create.
Which means women, and likely children, would be the best producers of sound energy. While scream energy is completely feasible in the monstersinc world, it's not really feasible in our world. And in the movie, it looked like they were using screams to power their devices directly, instead of, like what I'm doing here, of converting it to electricity first. I guess we're just a little too primitive for that right now. As always, please like and subscribe to the channel. Oh, no more of that.